Thank you. Good afternoon, everyone. Today, I will share with you my experience as an offensive engineer in Airbus evaluation team. So, just to introduce myself quickly, back in 2007, I was in the same position as you, obtaining my master's degree in computer sciences. And since then, I've been working in the cybersecurity fields, mostly on the offensive side. So something like a bit more than 10 years of experience now, and I've been messing around with debuggers and disassemblers for more than 20 years. Right now, my current position is I'm a member of the evaluation team at Airbus, and that's the experience I will try to share with you. My daily activities usually involve lots of reverse engineering, red teaming, firmware analysis, platform security, and this kind of stuff, mostly on the offensive side. So, this is what we try to share all together. So, the experience in the evaluation team and some real use case of evaluations that we have performed. Airbus' core business is to design and manufacture airborne products. That means aircraft, helicopters, satellites, for both civil and military usage. So we are not exactly the usual tech or IT startup. At the heart of the company, you will not find data centers, but you will find what we call final assembly lines, which are huge factories where all the pieces of the aircraft, for example, are put all together to produce the final products. There are many of them, some in Toulouse, France, where I'm located, some in Germany, in the US, China, and more recently, Canada as well. It goes without saying that to feed this final assembly line, this huge factory, you need a big supply chain with parts coming from hundreds, if not thousands, of suppliers. And in everything, if it goes well, at the exit of the final assembly lines, you will find some beautiful flying turtles like this one. It is one of the three A380s that have been produced for manufacture for a Japanese company named ANA. So there's a blue one, the orange one, and there's a third one, which is a green with the green paintings. So quite inspiring products. These are the products that are built and manufactured by my company. If you look at the figures on the right of the slide, these are the indicators that are usually expected from our customers. So we have range of the aircraft, seat capacities, fuel consumption, fuel efficiency, maintenance time, all these kind of things. So at this point, you may be wondering what is an evaluation team doing cybersecurity doing in such an industrial company. If we look at this infography, this cybersecurity outlook, actually there are many, many engagement points where we can go and use as a playground. Of course, there are the aircraft or the products themselves. There's more and more connectivity within the aircraft. It may be satellite communication, for example, to provide Wi-Fi, in-cabin Wi-Fi, communication with the ground, air-ground links, many of them, or the infrastructure of the ground also. Also all the manufacturing on ground, all the factories, and all the maintenance tools and sites. These are all the potential missions where we can go and intervene. So now I will try to present you what the evaluation team is doing inside the company. Our main mission is to evaluate the security of the company and its products by reproducing the behavior of a skilled and motivated attackers. Basically, it's some kind of red teaming on the products. These are our main mission, and I will come back on the term deep dive just after. Our other mission involve red teaming, more classical, what you would expect. We play attackers on the network. We play the sparring partner of the blue side, of the blue team, trying to reinforce and test the detection capabilities of the CERT and SOC team. We also develop our own tools. We do some purple teams, and also some expert appraisal when needed. What is very important is that our trigger is always the business. We are here to protect the business. That's what we do. So when a sensitive, when something is identified as business critical, it is a case of intervention for us. Or when there is a need for independent assessment in case of certification of embedded equipment, for example. When an evaluation is decided, is planned, the inputs usually are some security objectives that will be challenged during the evaluation, alongside with an attacker model. What is the attacker model we consider for this specific target or systems? The outputs of an evaluation are quite diverse, actually. Of course, it can be technical vulnerabilities. Something that I will stress to me is that vulnerabilities is not the end of the story. It's just a symptom of something else going wrong in the process. We will try to uncover fully workable attack paths, the same one that a real attacker could use. And of course, when identified, we will try to break them. We'll provide full security status report on the product or system we evaluate, as well as some recommendations, of course. All of these participate to input for risk reassessment and certification in case of embedded systems into aircraft or helicopters. The scope of our engagements, like you saw on the ecosystems, are quite ranged. We have been working on aircraft, of course, embedded systems providing GPS capabilities, satellite communication, SATCOM, both on aircraft and helicopters. We've been working on satellite communication and other services. We also work on OT, on some ICS equipment, ICS firewall. A couple of months ago, we were working with some of my teammates on the physical access control system, you know, the badges that you use to access restricted areas, for example, smart tools, CCTV cameras. On the more classical IT stuff, we've been working on video conference system, the thing you find in most meeting rooms to share some slides, for example. We've been working on Windows Master, some IT administration tool, like HP ILO features. I will come back on this a bit later, but also mobile applications and printers. What I've called the deep dive Singularity, what differentiates this mission from other kind of engagements, is the rationale behind it is that if a system is critical, we will invest the time that is needed. And it can mean a lot of time. This is really what is unusual. For example, our typical engagement time is usually 2 to 5 evaluators for a period of time between 1 month to 6 months. So that's quite a lot of time, and it is very unusual in this kind of industry. Usually it involves lots of experience because we are going from between very different topics, like we saw just before. Like I said, we aim to uncover fully workable attack paths. It usually involves either black box, gray box, or white box evaluation. Most of the time, still, it's mostly black box evaluation, and we do lots of reverse engineering during our engagements. We are working with very specific systems, avionics systems, embedded systems, and sometimes the tooling is not directly available off the shelf. So we have to develop our own tools. Some examples of tools we have developed are Gustav, which is specific tools that allow us to test for the robustness of partitioning operating system. Partitioning operating systems are quite regularly used in embedded systems to separate different domains. And BinCat also, which is a static analyzer that you can integrate with your usual disassemblers. We have the opportunity and we are granted the right to publish all these tools in open source, so that's quite a good thing for us. We have published many other tools, like BTA, for example, that is a tool allowing to perform some analysis on Active Directory, and plenty of other tools. We regularly find vulnerabilities during our engagements. So we have been trying to build a state-of-the-art security posture regarding that. We always report the vulnerabilities we discover to the vendors, because it helps to get them fixed and to raise our security level at the end. When working on the IT domain, we follow what is now well-accepted 90 days disclosure policies. Now it is widely accepted by most of the vendors, and sometimes it is a necessary incentive to have the vendors first publish, fix, and security bulletins and CV associated with the vulnerabilities that are reported. We have also our own front-end, if some people want to report some vulnerabilities into our own systems. Something that's very important and a key factor about our teams, we are something like 10 persons, And something very important I will stress is the diversity of background and technical profiles. That's really a must. There's a lot of knowledge sharing within the team, and that's very important. Beyond that, all of us share some kind of the same state of mind, what I've called this offensive thinking. I will come back later on this. And we all share this appetite for discovering and learning new things. We try to be also actors of the global security community, publishing at various conferences, like I'm here today, participating also in a conference committee, publishing our tools when we can, and also doing some training in universities and things like that. So now I will give you a concrete example of what a deep dive evaluation means to us. Servers are the building block of all the IT infrastructure. It goes without saying that when you have hundreds of servers, you don't want to come and physically plug into each of them to perform the administration of the servers. So for that, all the vendors are providing some administration feature, remote administration features. It's called Baseboard Management Controller, or BMC. In case of Hewlett-Packard Enterprise HPE servers, this feature is called ILO, HPE ILO. So why do we started to investigate to make a deep dive evaluation of these products? At world level, HPE servers is, depending on the year, something 20 to 25% of global market share. Within Airbus, we have hundreds of these servers. So for us, it is business critical. We cannot afford to lose them. So that's why we wanted to, we started to do this evaluation. And because also, regularly, during some other kind of engagements, like pen test or red teaming, we found this ILO BMC are sometimes exposed on the internal LAN. Just for those who don't know yet, this remote administration feature usually exposes some kind of web server where you can connect and you have access to a page where you can check the status of the servers, monitor temperature, health of the disk, health of the operating system, host operating systems, and plenty of things. So it's very powerful. If you own this, you own all the server. At hardware level, the BMC is a fully independent chip embedded on the motherboard of the system. It also has its own memory, its own network card. So it's really a machine within the machine. What is also a bit afraid that many of these systems, if you scan internet, are exposed directly on the internet. Quite often you will find them exposed on internal LAN of companies, corporate LAN, and quite often they are not well monitored, not well enough. So our methodology, when we did this deep dive evaluation of the systems, it was a pure black box study. There was very few public knowledge about this system, so we had to start from the ground. So we get back the firmware update from the vendor itself, and we started to learn the format, to dissect all of this. We had to extract all the firmware components, meaning the bootloader, kernel, userland image, etc. After that, we started to analyze the operating system that was used. It was a real-time operating system, quite classical in embedded systems world. It's named Integrity from US companies. We also performed a full analysis of the boot chain to understand what was the root of trust, or the signature was verified at each step of the boot, etc. Then we had enough knowledge to start rebuild the memory space of the ILO firmware, to start where the various modules were mapped, etc., what are the features. And then we started the analysis of the various exposed services like SSH, web server, IPME endpoints, etc. Quite quickly, we uncovered a very classical, typical vulnerabilities from the 90s, I would say. Using a sensitive and safe function like scanf on the HTTP header, connection HTTP header. The same in decompiled source code. So on the bottom of the slide, you see the scanf where the vulnerability resides. And using very well-known classical exploitation method, we're able to perform buffer overflow on the connection fields and to overwrite another variable that will tell if the user is authenticated or not. Meaning that with a simple HTTP header, we're able to take control, full control of the servers. If you can reach the server, you can own it. We did not stop here. We just didn't want to find a single vulnerability. We wanted to have a full understanding of the systems and the risks that are associated with its usage. So we continued to dig from there. From there, we had an authentication bypass. We turned it into remote code execution. We're able to execute the run code of the system. And from there, looking also at some hardware schematics from the vendor itself, we're able to discover that from the ILO systems, you are able to fully access the host memory, the memory of the host operating systems. So basically, it turns a remote administration feature into a gateway to the host operating systems. We've also been working on the newer version, ILO 5, which was the last one released, and they introduced something they called Silicon Root of Trust, basically a secure boot with the hardware anchor. And we are also able to find a bypass within this secure boot. So what it means for us, it is really a significant investment in time. We spent something like all combined 4 months for 3 evaluators, with Geoffrey Xarny and Fabien Perigo, who left the group since. So almost 1 full year of work for 1 person. And it was a pure black box study. But overall, the takeaway for we really believe that the takeaway for the group are really positive. We gain an extensive knowledge of a technology that is widely used and deployed within all the group, and an extensive knowledge of it and the risks that are associated with it. We discovered 4 vulnerabilities, critical vulnerabilities, one of them with one of the highest CVE score, 9.8 on a scale of 10, a bypass of a secure boot. But that's not the main things. Of course, all the vulnerabilities are reported to the vendor. The vendor published security fixes, security built-in, and using that, we're able to, of course, patch our systems. We're also able to raise the risk awareness within the group, and for ourselves, but also our suppliers and our customers. At the end, we had really a better and deeper understanding of our IT infrastructure. And we've been able to publish these results at various conferences, and then other researchers have continued this work, finding new vulnerabilities, for example, in the SSH components. So overall, the results are really positive for the group. Another kind of another engagement that we did recently was on the Xerox multifunction printer. Once you will join a company, you will find this kind of device everywhere. They are used daily by thousands of employees to potentially handle confidential data. And sometimes these devices are connected to the network, so they can be reached from everywhere. During this evaluation, the goal was we tried to exfiltrate confidential data without any credentials on the device, on the printer. We started, again, full black box study. We get the firmware update from the vendor side, started to extract it, decrypt it, and reverse engineering it. And this study was 40 days, 40% days. Again, many vulnerabilities were found, including some backdoor accounts used by the vendor to perform remote administration, some remote command execution vulnerabilities that would lead to full compromise, again, of the device, some passwords stored in clear text, on the device itself. We reported all our findings to the vendor as well. Some of the vulnerabilities are already fixed with security built-in published. Some are still in the process of being analyzed and fixed. We have been able to influence Xerox to publish this CV and security built-in. And yeah, my colleague Raphael Rigo will present more deeply all these works at Infiltrate conference in April, I think April. Yeah. So in a couple of weeks. So regarding the deep dive evaluation framework, we really believe that the outcomes are largely positive for the group. Of course, it is a huge investment, but the outcomes are positive. We invest time when it is needed when the system is considered critical for the business, with concrete impacts both internally and externally. And I really believe in the efficiency of a seasoned technical offensive team. And I will get back on these notions of offensive thinking. You may put different words on it, maybe creativity or something, but I'll try to provide some kind of personal thoughts and feedbacks about how the team operates and what kind of state of mind it takes to be efficient in this kind of job. The first one I will talk about is curiosity. It may be the main driver that we all share during our job. We always want to answer these simple questions: how does it work? What's the logic behind that? And to give you another example, I will tell you a personal anecdote that happens to me in 2010, I think. I was working in another company. I had a professional laptop, set up a BIOS system password, and a couple of months or many months later, totally forgot about it. So basically, I was screwed up. Quickly, I discovered that some people were releasing on the internet keygen that you could use to generate the supervisor password from just from the system tag of the laptop. So I really wanted to know how they did that. So I started to reverse engineering the BIOS myself to understand what happens behind the curtain. So I started to grab some information from the BIOS modders community. This community usually involves people who want to unlock some features, or at that time to play with Windows license schemes where some information were stored inside the BIOS. So we started to unpack the update, BIOS update, start reverse engineering code, and at some point I was kind of stuck because some code that I find in the keygen was not present within the BIOS. So it should be elsewhere. And I discovered that the BIOS vendor would actually hide some code, not in the BIOS, but in another totally different computational unit, which is called the keyboard controller. It is a different chip that is located on the motherboard of all your laptop. It is usually a low energy, low consumption processor, because it is always running even when your laptop is in sleep. And what I discovered at that time was that the BIOS vendor would hide some code inside this keyboard controller, and the BIOS will simply communicate with the keyboard controller to verify the master password that you input. Starting from there, I needed to understand the hardware to find what was the hardware architecture. I had no clue about it. After some research, I discovered that it used ARC Compact, which is quite unusual for this kind of stuff at that time. I had to write my own disassembler for it because nothing was directly available. I discovered that some insecure update process was used, and I was able to push my own modified firmware on the keyboard controller on this small chip. So from there, I wonder, what can we do? So my thought was, we can try to pivot and attack the main processor from the keyboard controller. And from there, I started again to analyze some components of the BIOS update. And one was the SMM code. SMM is one of the most privileged mods you can run on the main CPU. And I quickly discovered that there was some communication between the keyboard controller and the system SMM handler. And using a vulnerability I discovered, I was able to compromise the SMM handler to inject my own code, and providing thus a super stealth backdoor that you could hide within the keyboard controller firmware. The takeaway from all that is that all that time, curiosity was the main driver. It was a side project of me for many months, and it led to totally unexpected results. At the beginning of this study, my only goal was only to understand how we can generate the system password for the BIOS, but it goes much, much further. And in that process, I learned so much about BIOS themselves, so their builds, architecture, etc., about keyboard controller, hardware architecture, SMM, platform security, plenty of things. So one advice could be, don't stop to break things, try to repair them, build things also. That's very important, not to only break, but also build some things, experiment, and repeat all again, again, and again. Another state of mind that we all share in the team is the willingness to learn. As you can see, on the scope and various engagements we did, we quite often we go from totally different topics to another. Avionics systems, IT systems, CCTVs. So we need to quickly grab a lot of information, assimilate them, and be able to be efficient into the new evaluation. And for you, as young engineers, it may be a challenge, because right now, the pace at which the technology evolves is quite fast. Things evolve quite quickly. 10, 15, or maybe 20 years ago, one of the challenges was to access valuable information. Or how can I get proper information about the specific domain I want to study? Now, you are kind of, and I am also kind of overwhelmed by the volume of information that is accessible to me and to you. Today, if you want to be efficient or to master, for example, static analysis, reverse engineering, exploitation, browser exploitation, hardware stuff, you will need cryptography, you will need many lives to do so, and it will may not be enough. So you have still kind of, I think, pick your battles. And now there's more and more specializations. If you want to be very, if you want to go very, very deep into one subject, you need to spend lots of time inside. And one advice I will say is try to build a robust understanding of a domain or a subject and not to switch too often. If you spend your time only scratching the surface of a topic or a domain, at the end, it will not, it's my personal opinion, it doesn't work very well. Another advice is simply to team up. That's what I really appreciate within my team, with the diversity of profiles. You really get a boost in efficiency when you are able to work with people with different backgrounds. You learn quite much faster, and it's a really huge benefit to working in this cross-disciplinary team. It can be within the team or with external people, exactly like a scientific laboratory will do, trying to mount collaboration with researchers from all over the world. So teaming up may be a good solution to this challenge. Finally, and that will resonate with what Hélène said just before, try to always keep the mind and the willingness to challenge the assumptions and model. That's very important. Try to always expect the unexpected. What errors could have been made? Challenge what are the assumptions that are made by the designers of a systems. Attack the boundaries, attack the edge case. Detect if there's a drift between the specs and the implementations. All these kind of small things that we do naturally, that's very important. Just to illustrate this, in school, usually when I was in school, computer architecture, you have one processor with its associated memory resource. Is this model really enough to address the issue of platform security? Not at all. And that's what we try to do with my friend Alex Matrosov. We published at Black Hat this summer. Now, if you want to seriously think the platform security problem, you have to take into consideration actually many independent computational units that are all defining their own security boundaries. Of course, at the center of it, you have your main processor with, in this case, the BIOS firmware, U5 firmware, but around it, you have plenty of other computational units, like the embedded controller, like the GPU, network card, BMC if we're on a server, TPM firmware, hard drive, or SSD firmware. All of these are running their own code, defining their own security boundaries, possibly with their own secure or not update process. So the system is quite much more complex than what it was thought initially. And also some very practical problems. Many firmwares from various vendors, and possibly some of these vendors are receiving this firmware as binary blob and has no word on it. And what's important, the firmware security is not the sum of all the independent parts. It's much more complex. And in our study, we've again used the KBC to, we discovered that it was used by, for example, some security features from Intel named BIOS Guard. We provided an analysis of it. And we also discovered a weak update process on this KBC for some Lenovo laptops. And for example, another example, like Hélène said about the CPU, the processor. 10 years ago, the processor was a black box, and basically it was considered as reliable, trustable. Nobody looked at it. Nobody, except for a couple of individuals who still tried to scratch and to dig into it, and at some point they discovered that there was possibilities to sample the internal state of this processor. And now, since maybe 2 or 3 years, we have seen plenty of techniques to leak some information, to influence the behavior, spec meltdown being the most well-known. So keep this challenging in mind. And to conclude my talks, I will say that as an organization, I really believe in the efficiency of small team with a huge diversity of profile. It's really what I consider the most efficient way of working. The deep dive evaluation models that we deploy, I believe, have largely positive outcomes for a group. Once we identified business critical asset, we invest the time that is needed. We perform and we're able to raise risk awareness significantly. And doing so, we reduce our exposure. That's very important. As young engineers, like you are, in cyber or not, by the way, try to be curious and keep learning every time. It may be a challenge, but still you need to do that. Try to develop some robust understanding of the technology you manipulate, you use, or you're involved with. Switching too often may be not beneficial at all. And try to keep this challenging mind. Try to challenge everything new, everything that is considered as a supposition by others. And just to conclude with what I started with, industry needs your skills. So come challenge us with new and refreshing ideas. There's plenty of things to do. So thank you very much for your attention, and we'll be happy to answer to your questions.
So who has questions? Okay, so let's thank again.